Okay, for the first problem, we have a coin is thrown vertically upward from the ground with a velocity of 48.3 feet per second or 14.72 meters per second, and 1 second later, another coin is thrown vertically upward with a velocity of 96.6 feet per second or 29.44 meters per second. The question is, how far above the ground will the coins be at the same level? So both of them will have the same level in the air. So the given here is we have the two initial velocities here given for the stone 1, stone 2. For the stone 1, we have the initial velocity of 43.3 feet per second. Converting to meters per second, this will be 14.72 meters per second. Also for the stone 2, fast forward, and we have the given 1 second later. So let t be the time of the first stone minus the 1 second delay of the stone 2. So this will be stone 2 time. Okay, so for the stone 1, to solve this, since this is in terms of the height, so we can use the equation, the change of height, rectilinear equation. So rectilinear motion equation. So the height, so the change of x or height 1 be equal to the initial velocity times t minus the half of the meters per second squared of the gravitational acceleration. So this will be 4.905 meters per second t times t squared. Okay, so plugging in the given initial velocity, so this will be 14.72 meters per second times t minus 4.905 t squared. So for the second stone, okay, so for the second stone, its height will be height sub 2, and using again the formula we used earlier, so VO, so our initial velocity here is 29.44, okay, 44 times here the time of t, since it is delayed by 1 second, times t minus the gravitational constant acceleration, and t minus 1 squared. So we can expand this difference of a binomial, square of the difference of the binomial, so this will be 29.44 t minus 29.44. so we distributed it, and also here is minus 4.905, so here is t squared minus 2t plus 1. So we can also distribute this, so 29.44 t minus 29.44 minus 4.905 t squared minus 9.81 t plus, minus, because it is negative. Let's write it here, minus 4.905. So combine the like terms, so our H2 equation will be negative 4.905 t squared plus 39.25 t, because we add these both, and here also, we add these both, since this is positive. Okay, we add these both here, and minus 34.345. Since they have the same since they will meet at the same level, so height 1 is equal to height 2. So we can simply substitute the equations in each of the height. So this will be 14.72 t minus 4.905 t squared. And also in the left side, right side, is negative 4.905 t squared plus 39.25 t minus 34.345. So combining these two terms, combining this in its same terms, we can get that the time is 1.4 seconds. So to find the height of the height, we can substitute this 1.4 seconds any of these two heights because they are have the same height thrown from the ground. So meet each other at the ground, at the air. So substituting these two here, we can get that the height is 10.9 meters above the ground. So for the next question, problem, the motion of the particle is governed by the relation A is equal to 4t squared, where A is feet per second squared and t is in seconds. When t is equal to 0 and v is equal to 2 feet per second and s is equal to 4 feet, determine the values of v velocity and s distance when t is equal to seconds. So in this problem, we have a given equation of the acceleration, which is 4t squared, wherein this is feet per second squared, which is true, and we have a given velocity 2 feet per second at time is equal to 0, and also a s is equal to 4 feet at time t is equal to 0. So first, what we are gonna do is we are going to integrate the given acceleration equation. So a is equal to dv over dt, since this is in terms of time. So acceleration is equal to dv over dt and 4t squared. So we can cross multiply this dt to the other side. So this will be dv is equal to 4t squared dt. So now we can integrate the equation. Integrating the equation, so what we will get here is the v is equal to 4. Okay, 4. So t squared, 2 plus 1 is equal to 3 and over 3. So this will be 4 over t. So t cubed plus the arbitrary constant 1. Let's put it 1 there. So at time is equal to 0, our velocity here is, we have a given velocity here is 2 feet per second. So we can substitute this. So 2 feet per second and 4 over 3 and 0 seconds plus c sub 1. And now we can get that our constant is equal to 2. So next, since we have this constant, we can find the distance, the velocity when time is equal to, we need to find the velocities and distance at time is equal to 2 seconds. So at 2 seconds, our velocity here is v is equal to 4 over 3 times 2 raised to 3, which is equal to 8, plus the constant 2. So our v here, if we compute this, we will have a answer 12.67 feet per second. So this is the velocity at time 2 seconds. So next is we need to find the distance of the particle from its origin at 2 seconds. The time 2 seconds. So we know that v is equal to, we can integrate this. So v is equal to dx over dt, or simply we can use ds over dt is equal to 4 over 3 and t cubed plus 2. And then we need to multiply both sides by dt. So this will be, let's put it here, and this will be ds is equal to 4 over 3 t cubed plus 2 dt. And simply we can integrate this equation. So what we get here is the equation for the distance s. So the derivative, if we integrate these two terms respectively, what we will get here is t raised to 4 over 3, because this will be plus 1, 4, 4 over 4 can be cancelled, so 1 over 3 plus the 2t and the arbitrary constant second. So to get the, so at time 0, to get the arbitrary constant, so s is equal to 0 over 3 plus 0 plus c2, and we have a given 4 feet here as, so our c2 here is 4 feet, so our arbitrary constant will be equal to 4. So to solve from the 2 seconds interval, so to find s, or the distance of 2 seconds at, okay, at 2 seconds, what we have here is 2 raised to 4 over 3 plus 2 times 2 plus the arbitrary constant is equal to 4. So to solve this, what we will obtain a value of 13.33 feet. So this is the distance covered by the particle from the origin to 2 seconds time. So here is our last problem. Small steel balls fall from rest through the opening at a steady rate of 2 per seconds. So there is a two balls fall together, but in 1 second interval. Find the vertical separation h of two consecutive balls when the lower one has dropped at 3 meters. Neglect the air resistance. So this is a free fall equation. So the free fall formula here is height is equal to VOT plus, minus 1 half GT squared, or this will be plus. So the given here is two steel balls per second, and the given gravity 9.81 meters per second. Okay, and from ball 1 to the ball 2 is 3 meters height. So we know that they started at the initial velocity, so the initial velocity will be 0, so this will be cancelled out. So first is we need to find the height of the first ball. So h sub 1 is equal to 1 half times the gravity t squared. We can simply not the height, we need to find the time, since we have a given of the gravity and the height 3 meters. Okay, height 3 meters of the ball 1. So we can simply arrange this into t squared. So this will be time t squared, t sub 1 is equal to 2 times the 3 meters all over the gravity. So computing this, in the calculator, what we have is 0.78 seconds. Since the ball is released, they have a 1 second delay, since they are both from ball 1 to ball 2 to ball 1. So the time here is 1 second. So time 1 second minus 0.78 seconds, this will be the time of the ball, a second ball released. So what we have here is 0.22 seconds. So this is the time for the second ball here, second ball, first ball. So using again the formula here, so h2 will be 0.22, this is the time, times the gravity 9.81 meters per second squared all over 2. So what we have here is the height of the second ball is 0.24 meters. And since the height is from between of this, we need to find the height of vertical separation, vertical separation. So the total vertical separation here will be the height, and height 1 for the ball 1 minus the height 2 for the ball 2. So our height here is 3 meters minus 0.24 meters. So the height or vertical separation of the two consecutive balls will be 2.76 meters. So this is the final answer.